So this video is on Hess's law and some difficult questions, those questions where they give you multiple types of data rather than just combustion, just formation data. So have a look at this question, pause the video and try it yourself first. So the question reads, calculate the enthalpy of combustion of CS2 liquid given the following enthalpy changes. Okay. So again, there's two ways to do this. There's the shortcut method and the long way. To be honest, with a question like this, because it's quite difficult, you have two types of data. You've got combustion data and formation data. It's easier to understand with the cycle, I personally think, but I will also show you the shortcut method as well. So the first step is I like to always write down the enthalpy change that I'm trying to work out. I like to write that along the top. So we need the enthalpy of combustion of this CS2 molecule up here. So we've got the carbon disulfide plus the oxygen, and it's going to form carbon dioxide. That's what you get when you burn carbon, and sulfur dioxide. That's what you get when you burn sulfur. So we'll just balance it quickly. So we'll have put a 2 here, which means we've got a total of 6 oxygens, so we'll put a 3 here. Okay, and we'll call this is delta HC, because it's a Next, I'd recommend drawing in a couple of lines. So we'll draw a line down here and a line down here. These are going to be arrows, and the arrows are going to show which way the equation goes. So how do we work out what goes down here and which way the arrows go? Well, what you do is you look at the data you've been given. So you can see we've been given some combustion data for carbon and sulfur, and we've got some formation data for the carbon disulfide. So we can start with any one of these. It doesn't matter which one we start with. I'll start with this one here, so the carbon. So I look, have I got carbon so far in any of these two, in this equation up here? No. But have I got the product when you burn carbon? When you burn carbon, you make carbon dioxide, so yes. So I've got carbon dioxide here. So this is telling me the enthalpy change when I take some carbon and turn it into carbon dioxide. So let's put some carbon down here, and you can see that the energy change to turn this carbon into this carbon dioxide is minus 393. Now that's going to require, obviously, if I want to combust this carbon, I'm going to need some oxygen. So let's put some oxygen down here, some O2. I'll worry about balancing it later. Now I've only got if you look, I'm only making one carbon dioxide, so therefore I've only got one of this enthalpy change. If there was a 2 here, I'd have to times this by 2. Which way does the arrow go? Well, this is combustion data. So combustion is always a substance going from a state where it's not combined with oxygen towards a state where it is chemically combined with oxygen. So the arrow is going towards the products of combustion. Okay, I've now got some data for sulfur. It's also combustion data. Well, if you notice, this arrow is going towards sulfur dioxide, which is the product of combustion. So let's put some sulfur down here too. Now you can see we need 2 sulfurs to balance it. So how much energy does 1 sulfur give out when you burn it? Minus 297. So we've got 2 sulfurs we're burning. So it's going to be minus 297 times 2. And if we multiply these, add these together, that will give us the total enthalpy change for this reaction. So this is a combustion reaction going from sulfur, carbon, to the products of combustion. The only thing we need to do is we need to make sure it balances. So we've got 2 sulfurs, 2 sulfurs, 2 sulfurs, 2 sulfurs, 1 carbon, 1 carbon, 1 carbon, 1 carbon. So that's all balanced, but the oxygen doesn't balance. Right now we've got 6 here, 6 here, so obviously we need 6 down here. So let's just get a 3, and then we've got 6 down there. So this arrow down here, this arrow from here to here, if you add those up, is a total of minus 987. So to get from here to here, it gives out minus 987. So what about this one? What connects these two? Well, again, I look at my data. Does this one help me? No, there's no carbon going to the products of combustion. There's no sulfur going to the products of, there's no sulfur dioxide, so it can't be that. But if you look at this one, this is the formation of carbon disulfide. I've got carbon disulfide. Now, is the arrow going to go down or up? Well, because it's formation data, we are forming this substance here. So the arrow goes towards. Whenever you have formation data, the arrow always goes towards it. So we'll put the arrow like this. And what's the energy? Well, it's plus 88. Plus 88. Do we need to multiply that by anything? Well, we look at this number. Is there a number here? There's no number there, so it's just times by 1, so it's just plus 88. So we've now constructed our enthalpy cycle. We just need to do the clockwise, anti-clockwise rule to work out delta HC. So this rule is just for all enthalpy cycles, works for all enthalpy cycles, even the more difficult ones in A2. Basically, all of the clockwise arrows, so that's this one and this one, see they're going clockwise. All of the clockwise arrows equals the anti-clockwise arrows. So the only anti-clockwise arrow is this one. See this one here? It's going anti-clockwise. We've got clockwise equals anti-clockwise. So the clockwise arrows is our delta HC. That's what we're trying to work out. That red one, this one here, is also clockwise. So that's plus 88. And this one here is our only anti-clockwise one, so that would be minus 987. So delta HC equals minus 987 minus 88. Answer is minus 1075, and that's in kilojoules per mole. Kilojoules per mole. So I was saying there's a shortcut method for this one. There is. So the shortcut for this one is what you do is if you've got, because the equation you're asked to work out is combustion, and you're given some combustion data and one piece of formation data, we can actually use the equation combustion, which is reactants minus products. So you think combustion, you think crap, reactants minus products. For this equation to work, though, we need to have a non-combustion equation. So we need to write out the non-combustion equation. So if you look at this, you've got the formation of carbon disulfide. So let's write out that equation. So obviously, to make carbon disulfide, we're going to need some carbon plus some sulfur. And these are obviously in their standard states. So we'll put those in a second. Put a 2 here, even though sulfur is technically S8. It's allowed to draw, it's just S1. Okay, and we're going to form carbon disulfide. Okay, here we go. We've got this formation equation. So 1 carbon plus 2 sulfurs forms carbon disulfide. And we know the enthalpy change for that is 88. Okay, so now we need to write down our equation for combustion data, which is delta HF, that's this one, equals the sum of delta HC reactants minus the sum of delta HC products. So there is our equation, our shortcut. Now we know delta HF, that's that there already, that's 88. So we just need the reactants, delta HC for the reactants. Well, that's 1 carbon, combustion of 1 carbon, and 2 sulfurs. And that's minus delta HC combustion for the products. Well, delta HC combustion for the products, that's what we're trying to work out. So we'll just call that one delta HCP for products. Okay, so we'll rearrange that. So we'll have, so rearranging it gives us, by putting that over there and that over there, we have this equation here. And if you complete that equation, you end up with the same result as before, minus 1075 kilojoules per mole. So why am I teaching you both these methods? Well, personally, I prefer the previous method with the enthalpy cycle. I think that's better for understanding it. I'm just letting you know that you can do this shortcut method, but as you see, it requires quite a bit of manipulating and thought to be able to think, okay, I've got to put that one on top. But it just shows you can use it. If I was trying to learn just one, I'd probably just try and stick to the previous one, the first one, the actual making the cycle, because that's going to work in any situation. Because this one here works in most situations. You are able to do the shortcut. There are a few situations, actually I'm going to go through that next, where the shortcut method won't work.